History of smoke control. Let's start by looking at a brief history of where smoke control comes from. Now, smoke control is not new. We've known for years, since fire was first discovered, that if you put a fire in a room or a cave, you need to have a hole to get the smoke out, otherwise it'll smoke log it quickly. Now, the secret is how big the hole has to be. If the hole is not big enough and there's a fire, it'll come down and fill the thing. So you've got to make sure the hole's big enough. You've got to make sure that the smoke being generated can be extracted through that hole. Now, the secret of smoke control is to determine how big the hole has to be to prevent the smoke dropping below the design clear layer height. Now, in its simple form, this is the principle of smoke control. You determine either the area of ventilation required or the extraction rate required to maintain this clear layer height based on that fire size. Now, we've moved on since the caveman times, the early days, and now we've moved on since fire was discovered, and ventilation systems have improved quite significantly. Indeed, the development of extractors themselves have moved on, especially as a big significance during the Second World War, when ventilators were used for blackouts. You know, the bombing raids, we still wanted to operate at night, so we needed blackout. Problem is, if you black everything out, you can't get air in. So vents were created that could black out, but still let the air in. So significant development in extractors and ventilators were established during the Second World War. After the Second World War, Colt developed ventilators for industrial buildings. And this is when the sloping roof ventilator was developed, which dramatically reduced installation and your maintenance costs. And it was also designed to prevent downdraft from smoke blowing back into the building. They basically maintained it lower than 30 degrees so it won't blow back in, and in other words, it was effective. Now, in the 1950s, a major fire at a General Motors plant in the United States of America resulted in the development of the world's first automatic smoke exhaust ventilator. So that's where the first one came from in America, fire at a car plant. Now, the evolution of manufacturing and the production of these large single-storey industrial buildings, they need this type of development. They need these automatic smoke exhaust ventilators. Now, there was another big fire in Coventry at a Jaguar car plant, and that's when it brought these vents to the United Kingdom, to Britain. Now, this was expanded to protect warehouses in general, but it was mainly at the time for property protection. So it was to get the smoke out to protect the property. It wasn't until 1968 when a fire in a shopping centre made designers realise how much smoke could be generated in these malls. They realised how significant the loss of life could be if a fire occurred at peak times when thousands of people were in these buildings. And they realised that they could adapt the system to be used as a life safety system now, not just for property protection, life safety. And this led to significant research being carried out and formula being developed to determine these smoke parameters so that designers could effectively determine what was required in the areas to be protected. So all these formulas came from this research, and these formulas allow you to work out what area of events required, where you need them to maintain these smoke layers, and what extraction rate we're going to get, and what mass flow rates. You need formula to work out these calculations. Now, the main areas of concern at the time were atriums, and this is where the central void rises through 2 or more stories, potentially spreading smoke throughout the whole area. Unless, of course, these floors are separated from the atrium by fire-resisting construction, in which case you could actually argue the atrium is merely a big room with a high ceiling. If it's all fire protected all the way up, it's not going to spread. In a way, it's like a huge room with a high ceiling. That's what that is. Now, it should be readily obvious that a shopping mall of 2 or more stories represents a special case of an atrium, because it's an atrium with a single class of occupancy. The smoke movement will be similar, the smoke hazards will be similar, and the smoke control solutions can be expected to be similar. Now, the pivotal problem for both malls and atria is that smoke entering the void must not be allowed to endanger the safe escape of people in the mall or the atrium itself, or for people in any adjacent space open to the mall or atrium in any story. So you've got to protect all the people in these areas. Now, modern buildings are tending to look at more innovative designs. That's what they're looking at. Now, these buildings often have included within their design large spaces or voids and often integrated with many of the stories. Now, these large spaces have been described as malls, you can call them atria, arcades and light wells. But the generic term for the building type tends to be what we classify as an atrium. And by their very nature, they can often not comply with traditional building regulations, the normal approaches in terms of horizontal compartmentation and vertical separation. So they can't normally comply with building prescriptive documents, basically. Therefore, where they are proposed, you must demonstrate that they do not pose a risk to the occupants. To do this, there's a number of approaches available. You've got methods such as BR368, you've got the CIBSIG ID, and you've got PD7974, which all offers you alternative methods of compliance. And this course we're going to do will cover all these approaches. So we're going to look at all these approaches and integrate them all into the course. And it will also enable you to identify the impact of the varying approaches where some inconsistencies apply. Now, that covers the brief history and introduction to smoke control.